So for number 29 from Segel, the questions ask you about the pH of the solution when you mix 200 ml of 0.4 molar ammonia with 300 ml 0.2 molar hydrochloric acid. So again, these questions is mixing weak base and strong acid together. So in order to calculate the pH at equilibrium, you have to let the reaction start first. And this reaction is kind of like neutralization, but we need to use the ice table to see if at equilibrium there is any substance being left over. And then we can calculate the pH from what being left. Okay, starting from writing the equations of the reaction. So you have ammonia and hydrochloric acid. So whenever you mix base and acid, there's two products being formed. The first one is salt. So in this case, it will be ammonium chloride. And the second product is water. So this reaction is, you have to make sure that the reaction that you write is balanced. And we can see that right now our reaction is balanced. So then we can use the ice table approach. So to put the value in the ice table, you have to use to be consistent with the unit. If you want to use molar, you can put molar, but anyway, in the end, you still have to go back to like calculate the moles. But if you want to use the mole in the table, you have to put the mole for every substance or reagent here. So to calculate the moles of ammonia and hydrochloric acid, you can use the volume that you're given times by the concentration. So for ammonia is 0.2 liters times by 0.4 molar, and is equal 0.08 moles. Again, for hydrochloric, 0.3 liters times by 0.2 molar, and is equal 0.06 moles. So you can plug in this value into the initial line. So ammonia, you have 0.08, while hydrochloric, you have 0.06. So next step is to determine which one of these substrate will be the limiting substance. So in this case, you can see that hydrochloric acid, because one equivalence of ammonia will be react with one equivalence of hydrochloric acid. So the one, the substrate that have less than the other will be the limiting substance. So in this case, hydrochloric acid is a limiting substance, which you have only 0.06 moles. So the change amount of hydrochloric, of course, needs to be 0.06 mole, and the change amount of ammonia is also 0.06 mole, because one equivalence of hydrochloric react with one equivalence of ammonia. And then for ammonium chloride, you also create 0.06 moles of ammonium chloride. So at equilibriums, seem like hydrochloric acid will be 0, right? But ammonia is being left at 0.02 moles, and you also have ammonium chloride 0.06 moles. So we have two chemicals at equilibrium conditions. They are ammonia and ammonium chloride. So if you notice, these molecules is actually the conjugated pairs, right? So ammonia and ammonium chloride is conjugated pair. So if you have conjugated pair being left over at equilibriums, it requires you to use the Henderson-Hasselbalch equations to calculate the pH. So Henderson-Hasselbalch equations is pH equal pKa plus log B over A. So B will be your ammonia, while A will be your ammonium chloride. So these questions give you the value of Kb, but in the Henderson-Hasselbalch equation, you have to use pKa. So you have to change Kb to pKb and then calculate pKa from 14 minus pKb. And then you will have pKa equal 9.25. So pH, we want to know the pH, and pKa is 9.25 here. And then plus log B over A. So for B, actually in this equation, you need to plug in the concentration of the basic species and the concentration of acid species. But okay, so in this case, what we have at equilibrium is that ammonia we have 0.02, and this is moles, right? We put the moles value in the table. So 0.02 here is the moles. But to calculate the concentration, you have to divide the moles by the volume. And the volume in this case is a final volume after you mixing two chemicals together. So the volume of the final concentration will be 0.5 liters. And similarly for ammonium chloride, you have 0.06 moles, but you have to change it into concentration. So you have to also divide it by 0.5 liters. You can see that since these two chemicals in the same volume value, so you can cross out the volume here. So for the pH, you will get 9.25 plus log 0.33 here. And then the final answer of the pH, you will get 8.77. And from this pH, you can calculate the concentration of proton by taking the anti-log, right? Because it's from pH equal minus log proton. So you can take the anti-log. So it will be equal 10 to the negative 8.77. So these are the answer for these questions. So this I put explain the work for how you can find the pKa from the Kb that you are given. Let me know if you have any questions.